We're going to be doing Unit 2, Notes 5. So we're going to be talking about solving systems using any method. So basically, trying to identify when is it best to use substitution and when is it best to use elimination. So this is just kind of a chart that we made to talk about when to use each one. So when is it best to use substitution? Well, if it's solved for a variable, if it's in slope-intercept form, or if it's very easy to solve for a variable. Like maybe one letter has a coefficient of 1. It's pretty easy to solve for that letter because all you have to do is subtract something over to the other side. Elimination is easy to use if it's already in standard form. X's and Y's on the same side, thing that's just a number on the other side. If it has opposite signs or if it has the same number on the same variable. Those are all good places to be using elimination. So let's take a look at practicing some of that. So let's take a look at number 1. So for number 1, I first fixate on those 5. So I notice that each y has a 5 associated and that it's in standard form. So this is going to be an elimination problem. Substitution will still work, but elimination is probably easier. So I notice that the 5s already have opposite signs, so I can go ahead and I can already use elimination by adding down the columns. So 3x plus 2x is going to give me 5x. And then negative 5 plus 5y is going to cancel out. 7 plus 13 is going to give me 20. So now I'm going to go ahead and solve for x by dividing both sides by 5. And that's going to give me 4. So now that I know that x is equal to 4, I can really plug it into either one of those x's. So I'm going to plug it into the top one. So I'm going to take the x out and put 4 in instead. Minus 5y is equal to 7. 3 times 4 is 12, minus 5y is equal to 7. So now I need to solve for y, so I'm going to go ahead and subtract 12 from both sides. So I make sure I bring that negative down, so I get a negative 5y, and that's going to be equal to 7 minus 12, which is a negative 5. Since that negative 5 is being multiplied by the y, I can go ahead and divide both sides by negative 5. Well, negative 5 divided by negative 5 is 1. So then I'm going to write my solution out as a point, first my x, then my y. So my solution then is 4, 1. Next, let's take a look at number 2. So it's already solved for y. So y is equal to 2x plus 10. So I'm going to go ahead and plug that in for y in the first equation. So this one is very easy to use substitution because it's already solved for y. So that's what I'm going to do. I'm going to substitute out the y in the first equation with the 2x minus 10. So I'm taking the y out and putting 2x minus 10 in its place, and that is equal to 3. So I'm going to go ahead and distribute that in. So I get 5x plus 3 times 2, which is 6x. Plus, so then I'm going to do 3 times negative 10, which is negative 30. And that's going to be equal to 3. So 5x plus 6x is 11x, minus 30 is equal to 3. So now I need to add 30 to both sides to solve for that x. 11x is equal to 33. So then that 11 is being multiplied by the x. So I'm going to go ahead and divide both sides by 11. And I get that x is equal to 3. So now that I know that x is equal to 3, I can plug it into either one of these equations. Well, I'm going to plug it into the second one because that's already solved for y. So to me that makes it a little bit easier. So I'm going to take that x out and I'm going to put 3 in instead. So I have 2 times 3 minus 10. Well, 2 times 3 is 6, and then I have minus 10. 6 minus 10 is a negative 4. So I have x is equal to 3, and y is equal to a negative 4. So I have 3, negative 4 as my solution for number 2. Remember, coordinate points always go x and then y. So taking a look at number 3, what I actually want to do is I see that both of these are standard forms, but notice on the top, the x and the y are mixed up. So I'm going to rewrite that out so that the x is first. So 3x plus y is equal to 24, and 5x minus y is equal to 8. Now the reason why I rewrote it is because I noticed then that my y's have the same coefficient but opposite signs. So I'm ready for elimination. All I'm going to do is add down those columns. So 3x plus 5x is 8x. Our y's cancel. 24 plus 8 is going to give me 32. Then to solve for x, I'm going to divide both sides by 8, and I get that x is equal to 4. So now what I want to do is I'm going to plug in x for either one of these x's. It doesn't matter. I'll just plug it into the first one. So I have y plus 3, now instead of writing the x, I'm going to put 4 in instead, is equal to 24. So I have y plus 12 is equal to 24. So now I'm going to go ahead and subtract 12 from both sides, and I end up getting that y is equal to 12. So x is 4 and y is 12. So I'm going to write that out as the coordinate point, just like that. Now let's take a look at number 4. So for number 4, I see that it's already in standard form and that my y's have opposite signs. So I'm going to choose to use elimination. Again, substitution will work, but you might have to deal with some fractions. So that's why I prefer elimination. So I want to get my y's to have the same number. So I'm asking myself, what is the smallest number that those y's are going to multiply to with 3 and 5? What's the smallest number that 3 and 5 multiply to? And that's going to be 15. So to multiply 3 to get to 15, you need to multiply by 5. To multiply by 5 to get to 15, you need to multiply by 3. So I'm going to multiply each of those out. So when I multiply the top part by 5, remember that I am multiplying everything across the top by 5, including that 16. Same thing for the bottom. I'm multiplying everything by 3, including that negative 4. So now I'm ready to use elimination. My y's are going to cancel, and then 25 plus 9x is going to give me 34x. 80 minus 12 is going to give me 68. So now I'm going to go ahead and divide both sides by that 34. So then I get that x is equal to 68 divided by 34, and that's going to be equal to 2. So now that I know that x is equal to 2, I can plug it into either one of these, or I could even plug it into one of them that I created. Now these have smaller numbers, so I prefer to pick one of those. So I'm just going to use the top one. So I'm going to take x out completely, and I'm going to put 2 in instead. And then I'm going to add 3y and set that equal to 16. So then I get 10 plus 3y is equal to 16. So then I need to subtract 10 from both sides because it's a positive 10. So to get over to the other side, I'm going to subtract it. So then I have 3y is equal to 6. Then divide both sides by 3, and then I end up getting that y is equal to 2. So now I'm going to write that out as the coordinate point, x and then y. So let's take a look at number 5 now. So I see for number 5 that it is already solved for y. So that means I want to use substitution. So I have that y there, and I'm going to plug it into the y in the second equation. So what I'm going to do is I'm going to keep the rest of the equation the same, and then where that y is, I'm going to take the y out and put 4x plus 11 in instead. So I get 3x minus 2 times 4 plus 11 is equal to negative 7. Now I need to take that negative 2 and multiply it to everything in there. So I have 3x minus 8x plus negative 2 plus 11 is negative 22 is equal to negative 7. Well, when you do 3x minus 8x, that's going to give you a negative 5x. Minus 22 is equal to a negative 7. So I'm going to go ahead and add 22 to both sides. Well, a negative 7 plus 22 is really the same as 22 minus 7, which is 15. So I'm going to go ahead and divide both sides by a negative 5, and then I end up getting that x is equal to a negative 3. So if I go back up to the original equation, you can plug it in for either x. But I really want to plug it into the first one so that I can very easily, solve it because it's already solved for y. So what I'm going to do is I'm going to substitute out x and put negative 3 in instead. So 4 times negative 3 is going to give me a negative 12 plus 11 is a negative 1. So then I have negative 3, negative 1 as my solution for number 5. So let's go ahead and let's take a look at number 6. So I see that I have standard form opposite signs, so I'm going to use elimination. So I want to figure out the smallest numbers that 3 and 4 multiply to. Well, the smallest number that they both multiply to is going to be 12. So to multiply from 3 to get to 12, I'm going to multiply by 4. To multiply 4 to get to 12, I'm going to multiply by 3. So I'm going to multiply that entire top equation by 4. And this is what I get when I do that. Then I'm going to take that bottom equation and I'm going to multiply it by 3. And this is what I get when I do that. So then now we can add down the columns. 16x plus 9x is going to give us 25x. Then I can cancel those out. 76 plus 24 is going to give me 100. So now I can solve for x by dividing both sides by 25. And then I get that x is equal to 4. So now I need to plug in x, and it doesn't matter which equation. I'm just going to pick the first one. So I'm going to substitute x out completely and put 4 in instead. And then I'm going to have 3y is equal to 19. So 4 times 4 is 16, plus 3y is equal to 19. So I'm going to subtract 16 from both sides, and I get that 3y is equal to 3, divide both sides by 3, and I get that y is equal to 1. So I'm going to go ahead and write that out as a coordinate point. First my x, then my y. So that is my final answer for number 6. Taking a look at number 7, let's go ahead and write out this word problem. So Deshawn and Shauna are buying flower bulbs for a school fundraiser. Customers can buy bags of windflower bulbs and bags of daffodil bulbs. So Deshawn sold 12 bags of windflower or 10 bags of windflower and 12 bags of daffodil for $300. So what I'm going to do is I'm going to let X represent the price of windflower. And I'm going to let Y represent the price of daffodil. So then let's go ahead and let's get this set up together. So he did 10 bags of windflower at price X, and then he did 12 bags of daffodil bulbs at price Y, and that was $380. Taking a look at Shayna, she did 6 bags of windflower at price X and 8 bags of daffodil bulbs at price Y, and that was $244. So now we need to solve this, and I suggest by solving it using elimination. So we need to figure out what the smallest number that some of these multiply to. So I'm going to focus on X. So what's the smallest number that 10 and 6 both multiply to? And that's going to be 30. So what do I need to multiply 10x by to get 30? I need to multiply it by 3. What do I need to multiply 6x by to get 30? I need to multiply it by a -5. And the reason why I did a -5 is I want to make sure I create those opposite signs. So up top, I have 30x plus 36y is equal to 1,140. On the bottom one, I'm going to have a -30x minus 40y is equal to 1,220. So I'm going to go ahead and have you guys finish solving this on your own for me, please. So I want you to finish solving that. Remember that you need to label the x coordinate, windflower, and the y coordinate, daffodil. Let's take a look at number 8. So at a store, toothbrush costs X dollars and soap costs Y dollars. One customer bought 2 toothbrushes. So they did 2 toothbrushes at price X. That's hard to see. So we did 2 toothbrushes at price X. So I'm going to go ahead and pick a different color here. So 2 toothbrushes at price X, okay? And then that's going to be equal to or plus 1 bar of soap at price Y, and that was $11. Another customer bought 6 toothbrushes at price X, and then 5 bars of soap at price Y, and that was equal to $38. So this is already set up in standard form, but you could very easily use substitution. This equation is very easy to solve for Y. All you have to do is subtract the 2x over to the other side. And then you end up getting that y is equal to a -2x plus 11. So now, since we've solved that equation for y, we're going to plug it back in for this y right here. So then I have 6x plus 5. Now instead of writing y, I'm going to put in that -2x plus 11, and that's going to be equal to 38. So I'm going to let you guys finish solving this one out on your own. It's $4.25 for a toothbrush and $2.50 for soap. And that concludes your note video for today. Thanks for listening.